For our t-shirt sales campaign math assignment, our group members were Jules LeBlanc,
Jose Camis,
and Ansh Gandhi.
Our target audience was male Quebec Allophone McGill students, which was roughly about 2,400 students total.
We wanted to create a design that would fit the target market we were aiming at. The design we chose was basically to design a t-shirt that was inexpensive and simple. Our plan to reach this market was to hand out flyers at different locations. We chose three specific locations. The first one was outside of Vivo, the second one was the Y intersection at McGill, and the third one was all along Rue Sherbrooke West.
To reach this audience, we decided to hand out the flyers at certain times of the day, such as the middle of the day, which was in between classes, because the students would be most active and outside at those times.
Marketing plan will comprise of a reachable target market of 2040 students, which is 85% of our total target market.
The fixed cost that we were expecting to pay was the price of the stall, which was about $50, making flyers, which was $40 because each was 4 cents each, transportation, which was $10. Overall, that added up to be about $100 in total.
To determine our unit cost, we used half of our reachable target market, which was 1,020 people. According to the pricing chart, we determined that the cost for each T-shirt would be of $3.90. We anticipated a total revenue of $3,978 by multiplying the price times the quantity demanded.
The method that we used to reach our audience through polling was on-the-spot polling. In this way, we asked people randomly on the street. Overall, we asked 50 people about how much they would pay for the shirt. 33 of them said that they would pay less than $5. A very common value was either $5 or $10, and no one wished to pay beyond $12. Overall, people were not extremely responsive and just gave common values.
Even though people were not willing to pay what we initially expected, this did not affect our planning because we still planned on selling the t-shirts for cheap.
According to us, the best and most effective model that represents our data is the quadratic model. This is because of a few reasons. The quadratic graph showed an upward-facing parabola. It showed a strong positive correlation, and it had a negative slope, which is indicated through the positive x squared value and the negative x value. Also, the trend line fits perfectly over mostly all the data points. And lastly, as established in part B, a graph indicates a strong relationship when the value of the correlation coefficient value, r squared, is closest to -1 or +1, and our value was 0.98555, which was closest to 1 compared to other models. We observed that an increase in price caused a decrease in demand. For example, for a price of $1, demand was 2,112 t-shirts, and for a price of $9, demand was 576 t-shirts. So that shows the negative slope. And as part of the other task, if we added $5 to our maximum price, which was $20, we get $25. And if we plug in this value into the x value of our demand function, you get 463.475, so approximating to 463 t-shirts. To check whether it was increasing or decreasing, we compared it to the last value of our demand, which was 0. So this shows that the graph is increasing from 0 to 463. And we observed that this increase is unreasonable because demand will not go up with an increase in price. Also, as part of our polling, students weren't willing to pay $20, so $25 was out of the question.
However, in terms of this part of the assignment, this model was the best fit.
We multiplied the unit cost by the demand function, and then we multiplied the demand function by x, which represents the selling price. To find our cost function, we multiplied the unit cost by the demand function.
We inputted our demand function and costs on the revenue and profit Excel graph to find the maximum values.
To find the price that maximizes revenue, we calculated the derivative of revenue function and set it equal to 0. That resulted in two x values. We rounded the values to the nearest cent to get the math results and the nearest dollar to get the business results. To find the price that maximizes profit, we calculated the derivative of the profit function and set it equal to 0. That resulted in two x values. We rounded the values to the nearest cent to get the math results and the nearest dollar to get the business results.
We figured out the price that maximizes revenue is $6 and the price that maximizes profit is $8.21. Both values matched our maximum values. We calculated the rate at which the price that maximizes profit changes at the price that maximizes the revenue by using the math results price, which we found was about $751.95.
Companies always intend to maximize profit, a concept known as bottom line. According to our possible prices, we wish to sell the t-shirts at the price of $8, which is the price that maximizes the profit. This price represents our net earnings or profits and doesn't account for expenses or costs. Based on this price, we calculated our demand to be 679 t-shirts. When we compare this value to the pricing chart, we determine the same unit cost of $3.90.
Because half our reachable target market was 1020, we paid for this demand in advance. We inputted 1020 into the Excel data and got the following demand function. After calculating the revenue and cost functions, we get the following profit function. However, we've just calculated that we needed only 679 t-shirts and sold 679 off the 1020 t-shirts. So we didn't end up selling 341 t-shirts.